Hey there. This is just going to be a quick little tutorial on how to make your torque wrench geometry in Fusion and then import it into ANSYS. Um, Even if you've used Fusion before, importing step files into ANSYS has a few hiccups, so it'll be good to watch until the end and stay refreshed on that. So we'll start in Fusion. Um, if you want for your own organization, you can make a folder to put your project in. It'll open up into just an untitled file. Start just by saving it with a name. And once that's saved, we can start making the geometry. We're just going to be a bit particular about how we orient it for the sake of consistency and later comparisons to your other analyses. So if we go over to the geometry, we're going to start by making this rectangle from the example geometry. So you can see that's dimensions b by h. Scroll down. B is 0.5, h is 0.75. And we want this to be on the XY plane. So if we hit create sketch, you can orient it so that, just a second, we want the X dimension to be the width and the Y to be the height. So click 2-point rectangle, click on the origin, drag out, and if you've never used Fusion before, this is a bit helpful. You can just tab to go between your different dimensions for your sketches. So we want the width to be 0.75, and then tab over to make the height 0.5. Hit enter, and now you've got your kind of profile there. You can hit finish sketch. You want to go to extrude, and then we're pulling this along in the positive Z direction. In this case, the length from one end to the center of the drive is going to be 16 inches, at least for the demo geometry. And in this case, we're going to orient the drive near the origin. So we're going to pull this out 16, and then add 1 more inch. If we're going 16 from here to the center, we need a bit more space on the end. So we'll bring it up to 17 and hit enter to finish that. And then to make the drive, go over here, check the dimensions for that. That's going to be 3/8 of an inch on each side and 1/2 an inch tall. And we're going to be a bit particular with how we kind of segment this, which I'll show you now. So you can create sketch, and you want to make it on this top face here. Click on that. Again, just a rectangle. You can drag out. Another convenient thing is you don't have to type a decimal value for Fusion dimensions. If it's 3/8 of an inch, you can just do 3/8, tab, and it knows that's 3/8 of an inch. And be sure to set your units as well. You can hit enter. And now we need to position this on our handle. So we want to center it in X. So quick math, if our handle is 3/4 of an inch wide and our drive is 3/8 of an inch wide, that leaves on each side, I believe, 3/16. Yep, to center it. And then we want this to be 16 inches on center from the far end, but we can dimension it from here. So if it's 17 inches in total, we want it to be 1 inch away from this end on center. So that's 1 inch minus 1/2 of this width. So 1 inch minus 3/16, which is 13/16. Click finish sketch there. Now we're going to extrude this out. This is the kind of careful part. Let's go back to the dimensions. We want a segment down here. We want the whole height to be 1/2 an inch, but then we're kind of separating out this top 0.4 inch bit. So to make that, we're going to extrude this by 0.1. And then over here in the extrude panel, instead of operation join, that's going to make this one body. We're going to click new body, so that way these two are now separate. And if you hit OK, go to the tree over here and expand bodies, you can see these are separate. And we're going to do the same thing. For this surface, you don't need to make another sketch. You can just click this surface, and we'll do 0.4. Again, you're going to switch join to new body, and there's that. We also want to make fillets on these corners. Those are going to be 0.05 inch radius. So to make a fillet, it's up in the ribbon right up here. So you can just click that, and then you're going to click all 8 of these vertices, edges, I guess. And you can type 0.05, and now you have your fillets. Last thing we can do, this just helps with organization, is make a component. Or second to last thing. Create components from bodies, and you can see that makes a component down here that puts the handle body into there. And to kind of say that this is all one component, it's just split into 3 different bodies, you can just drag the other 2 bodies over. And as another point of staying organized, we can rename all of these bodies. So you can rename that first body to handle. The base of the drive we can call drive 1. And the top of the drive will be drive 2. And if you want, you can rename the component up top, right click, rename, change that to torque wrench. Once that's done, you can save one more time. And then we want to export this in order to get it into ANSYS. We're going to do that as a step file. So click on this file icon up here, export. Normally it defaults to this Autodesk Fusion Archive. So you want to click this, scroll down to step, and set this export location to somewhere you can find it. Note the default is some random folder, so you might export it and be like, where'd it go? So know where it's going. And then you can click export. Now heading on over to Workbench. As a reminder, to start ANSYS, you want to type Workbench into your Windows search bar. That'll open up this window, which is where you access basically every other part of ANSYS from. If you just type in ANSYS, you'll get some other program that isn't useful. So search for Workbench and run that. It might take a bit to start up. Once you're in Workbench, you're going to see probably something like this, where you only see analysis systems. We want to do a static structural analysis, but if we're focusing on geometry for right now, what you can do is click on Component Systems, scroll down, and go to Geometry, and just drag that in. That'll let you only load in a geometry, but if you want to use it for something else later, you can do static structural, let that load in, and then drag this geometry over, like left click drag to this. And now you have this block that dictates the geometry, and this one that references back to here. You could just do this with just this block, but kind of passing things by reference is useful, so I figured I'd show you that. Once you have geometry, you're going to right click, import geometry, and browse. Go to that folder that you exported your step file to, and just load it in. It should load pretty quickly. Once you get that green check mark, you know you're good. It should default to opening in Discovery, but to make sure, you can right click, edit geometry in Discovery, and give that a bit to load up. Once you're in Discovery, if you oriented your part right and did everything right, you should see it show up like this. You can middle mouse wheel and click around to drag and orient it, or you also have this down here to kind of pick a view. The main thing we need to do here is share topology. Basically, if you go up to the tree up here, expand, it recognizes the 3 different bodies, but we want to tell ANSYS that, hey, this is actually part of one connected body with 3 subparts. So to do that, you'll go up to this top ribbon that says prepare, and we're going to do what's called share topology. So you can click share over here. And for now, you don't need to know what all these tools do. If you just hit complete, it'll kind of auto-detect the geometry. And nothing changed up here, it looks like, but if you zoom in, you can see these lines are purple, which means these edges are shared, which is a good sign. Not shared faces are turned on, but you can see we don't see any red faces. And if you click shared, you can actually see that these 2 faces, which are the interface between handle and drive 1 and between drive 1 and drive 2, are shared. So they're still separate bodies, but now ANSYS knows, hey, these 2 faces are kind of mated together, which will of course be important once we're putting loads on this thing and trying to see how it deforms. You can click out of that or hit escape. And with that done, there's nothing else you need to do in here. You can close this or Alt-Tab over to Workbench. And of course, you're going to want to save. So first, you can save project, give it whatever name, and it'll save that as a WBPJ, which is a kind of Workbench project file. Give that a moment to save. But if you want to move that file somewhere, the WBPJ format saves as a file in a few folders. That can make it easy to kind of lose different parts of your project. If you just want one kind of compressed file that has everything, after you save, you can do File, Archive, and you can see that saves as a WBPZ. There's no results here, so we can just hit Archive, and that'll export the file as a single file that contains all of this. It'll have your geometry, all your setups, all your results if you have those. And with that, you are all set.